Question number 2. For a 4-unit class like statistics, that's our class, right? 4 units plus the 2-unit co-rec if you're doing that. Students should spend an average of 12 hours studying for the class. I guess they mean every week, right? Because they say, you know, the old college saying 2 hours outside for every 1 hour inside. So if we spend 4 hours a week inside class, 4-unit class, that means you should spend 8 hours outside, so that's 12 hours a week total on the class. A survey was done on 20 students, and the distribution of total study hours per week is bell-shaped with a mean of 14 hours and a standard deviation of 3.2. What in the world are they talking about? What do they mean by bell-shaped? Well, this is our basic introduction. We're going to do a lot more with it later to a bell curve. Let me come on down here. And so I'm still working on number 2 here. And I'm going to make for you a bell curve. So how does this work? Let me try that a little bit better. So we're going to have a bell curve here. Do the best I can. Okay, so it looks like a bell, hence the name. So the bell curve, what they're saying when they say this line up here, when they say on number 2 that the it's bell shaped, and they what they mean is we draw this bell, and then we put right in the middle the mean, which they told me what that was, right? On question 2, it says mean of 14 hours. So let's come on down. That means the average student in the statistics class is spending 14 hours a week studying for the class. Now, not everybody is completely average, are they? Not everybody does exactly the average thing. Some people do more and some do less. So what I'm going to do here, oh, it's not a very good one. Let me see. I'm going to draw that line. And that line, and then that line, and that line, that line. Extend that. Extend that a little bit. Okay. Okay. So what am I doing? I'm putting 3 lines to the right and 3 lines to the left of the middle line. Everybody see that? 3 to the right, 3 to the left of the middle line. This is what we're going to do a lot of this later. And what these lines represent is this is the mean plus 1 ST, 1 standard deviation. In fact, I'm just going to call it M for mean because I don't have room to write all that. So it's the middle plus 1 standard jump. In other words, we go 1 to the right. And this is going to be the middle minus 1 standard deviation jump. What do I mean? What's standard deviation? Well, it says it right here on the problem. It says the standard deviation is 3.2 hours. See that? Standard deviation is 3.2 hours. So that means every one of these jumps it's going to be 14 plus 3.2, so that'll be 17.2. This will be 14 minus 3.2, so that'll be 10.8. So what does that mean? What does that mean? That means that here's the average student. The average student in the statistics class that they surveyed is spending 14 hours a week studying for the class. But not everybody's average. Some are doing more than the average. Some are doing less than the average. Right? It's the average, which means it's the middle. Some are doing more. Some are doing up to 17.2 hours per week studying for the stats class. Some are doing as little as 10.8 per week studying for the stats class. Does that make sense? That's what the standard deviation is. And then you do it again. To get all the way to here, this is 2 jumps to the right. And this will be 2 jumps to the left. Everybody seeing that? 2 jumps to the right, 2 jumps to the left. All right, so that means, let me change here. This is going to be the middle. Whoops. This is going to be the middle plus 2 standard deviation jumps. So this is going to be 14 plus 2 times 3.2. Everybody see what I'm doing there? Use your calculator. That's going to be 20.4. And this one over here will be the middle minus 2 standard deviations. So this will be the 14 minus 2 times 3.2 because it's 2 jumps to the left. So that comes out, let me use my calculator here, 14 minus 2 times 3.2 is 7.6. All right, are we good so far? So this is 2 jumps left and 2 jumps right. And now we're going to go even further. Now we're going to go 3 jumps to the right and 3 jumps to the left from the middle. All right, so what is this spot out here going to be? This is going to be the middle plus 3 standard deviation jumps. So that's going to be 14 plus 3 times 3.2. Right? See, I'm just taking the middle number 14 and I'm adding 3 times 3.2. Right? Let me write that a little better. The middle plus 3 times 3.2, because 3.2 is the standard deviation. So you're just adding 3 standard deviations. 3 standard deviation jumps comes out 23.6. This line right here, so that's this line right here. This one's going to be the middle minus 3 standard deviation jumps. So whoop, that's going to be the middle, which again is 14 minus 3 times the standard deviation, 3.2. 14 minus 3 times 3.2. I'm getting 4.4. So there's that line at 4.4. All right, so let's make sure we're all clear on that graph. All right, so is this good? So this is question number 2 on lecture homework 2.3. So we have the middle. So how did I make this whole bell curve thing? Well, I just drew a bell curve and I put right in the middle the mean. They told me the mean was 14. And then for every jump, I took the mean, the 14, and I added 3.2 because that's the standard deviation. They told me that right up here. They said the middle is 14, the middle is 14, and the standard deviation jump is 3.2. So I took those numbers down here, and I put 14 in the middle, and then I added 3.2 once, I added 3.2 twice, I added 3.2 3 times. That's how I got these numbers. And then when I went to the left, it's subtraction. So I took the middle 14 and I subtracted 3.2. Then I subtracted 3.2 twice because this is 2 jumps. And then I subtracted 3.2 3 times because this is 3 jumps. So now I've got this bell curve. What is this bell curve showing? It's showing how the students are distributed in the stats class, meaning the average person does 14 hours of homework every week. Spends 14 total hours, lecture and homework, on the class every week. But some people do more, 17.2, some people do less. Some people do a lot more, 20 hours a week. Some people do a lot less. Some people do crazy more, but not very many. See how the curve comes down? There's not very many people that are spending 23 hours a week on the class. I bet not. And some people do hardly any. There's not many of those either. See how the curve is really high in the middle, which means most people are right around the middle, and the curve comes down really low on the right and the left. That's the point of the bell curve. Most people are in the middle. Now, there's all kinds of things in real life that are bell curve. We call this normal distribution because it's so normal. It happens all the time. Normal, in fact, it'd be better if I wrote it down below. This is called being normally distributed because it's what normally happens. So you measure IQ scores or heights or weights or the weight of leaves on the tree, and you measure them all, you're going to have some average weight, and most of the leaves will be the average weight. Then there'll be some that are really heavy leaves and some that are really light, but not as many. You'll have this bell curve kind of thing. It happens all the time. It's used all the time in business and science, and you'll see it all the time. Things are bell-shaped, normally distributed. Anyway, let's get back to the problem. So here's the important thing for us. There's certain percentages which are in here. This is going to be, in fact, let me write it down below a little better here. This is going to be 34% and 34%. This is going to be, so see, look at the numbers up here. They're telling me 68, 95, 99.7. Where are we getting those? Well, 34, 34. This is 13.5, 13.5. Like that. You know, what does that mean? Why am I doing this? Well, that means that between these two lines right here is 68% of all the people. That means 68% of all the students in the stats class spend between 10.8 and 17.2. 68% of the students spend somewhere between 10.8 and 17.2 hours per week on the class. That's what that means. I just added 34 and 34 to get 68. Everybody see that? And now, if we extend that out further, we can go this line and this line. If you add up all four of these percentages, you know what you're going to get? 95%. 95% of all the students in the stats class spend between 7.6 and 20.4 hours in the class. That's almost everybody, 95% of the class. And then the final category, I'll extend this line up, this line up. If we go all the way like that, if you add up, oh, and I didn't even give you the last percentage. This last one is 2.35. 2.35%. So if you add all those up, you're going to get 99.7%. Almost everybody in the class studies somewhere between 4.4 and 23.6 total hours on the stats class. That's 99.7% of the class. So that's what, now you might want to know, Mr. Where'd you come up with these numbers? Well, those are the numbers for a normally distributed curve. That's what a normally distributed curve means. It means these numbers are the case, you know, between the first two lines, the next two lines, and the third lines. So that's exactly what it means. So you're going to want to put this bell curve on your notes for the next exam. You're going to want to have this bell curve right on your notes because you will need it. All right. Having made that bell curve, let's go back up now and answer the questions. What is their question? It's saying 68% of the students spend between blank and blank hours. 68%. Let's go back and take a look at it. 68% of the students, where do they go? 68% go from there to there, don't they? Which means 10.8 and 17.2. 68% of the students in the stats class spend between 10.8 and 17.2 total hours on the class every week. 10.8 and 17.2. So that's what we fill in.
Mr. Heron?
Question?
Yeah. How'd you get 34%?
Yeah, there's no way to come up with that. It's just, I just know it. And that's a great question. That's exactly what I'm telling you. I didn't come up with it. I just know it. I just have it memorized. You don't need to memorize it. You would just write this bell curve. Those percentages will always be the same. Anytime you draw the bell curve, it means 34, 34. The numbers on the bottom will change from example to example. They'll give you a different mean and a different standard deviation. But these percentages, 68, 95, 99, will never change. They're always the same. That's what it means to be a bell curve. It means those particular percentages. And so what you do is you just write these in your notes. You can use your notes on the exam and on the homework, of course, and then you just always use those same percentages. That's just what they are. It's a deep mathematical proof about why they are that way. We're not going to go there. We just use them. Good question.
Thank you.
Yeah. So, and then the next question, it says, is 95 are between what two numbers? Well, we just go back down. We go, okay, 95 go from here to here, right? Which is 7.6 and 20.4. 95% of the students in the stats class spend between 7.6 and 20.4 hours on the class. 7.6, 20.4. 7.6, 20.4. Final question. 99.7. Between what two amounts? 99.7. So 99.7 goes there and there, this line, which is this number and this number. Right? So 99.7% of the class spend between 4.4 and 23.6 hours on the class every week. 4.4, 23.6. So 4.4. Oops, that's not very good writing. 23.6 on the class every week. And there we go. That's how we do number 2. So how do you know you're supposed to do that whole thing? They say bell-shaped curve. When they say bell curve, then you know, oh, I got to draw the bell curve. And how did I do it again? Well, they also told me the mean, which is the middle, and they told me the standard deviation is 3.2. That means every line goes up or down by 3.2. Does that make sense? They tell me the middle, and they tell me how much the lines jump by on the bottom. So the middle is 14 on the bottom, and they jump by 3.2. So I just come down here, and I see what I did is I just put 14 in the middle, and I added 3.2, add another 3.2, add another. So these numbers come by adding 3.2 every time. And then on the left, I subtracted 3.2 once, subtracted again, and again. You just subtract 3.2 every time. The percentages are always the same. That's what I'm telling you. 68% between the first two lines, 95 for the next two, and 99.7 for the 3 lines right and 3 lines left. The percentages are always the same. The numbers on the bottom change. So there we go. Here, I'll just leave it right there. There's how we do that.